In a continuing effort to improve the safety performance standards of rigid mine ventilation ducting, engineered flame tests were carried out by Schonberg Industries Limited of North Bay, Ontario, Canada, and based on similar tests propagated by the United States Bureau of Mines Investigation number 9085. In this test procedure, identical lengths of rigid FRP mine ventilation ducting, 10 feet long and 16 inches in diameter, were suspended from a steel frame in a vertical position and exposed to the flames of heptane from a metal tray positioned approximately 3 inches from the bottom of the suspended ducting. The tray was nominally 22-inch diameter and filled with an approximately 1/4 inch of the top with water and the remaining space topped off with heptane. The USBM report documents the heat output of the heptane as 16,300 British thermal units per minute. In the test conducted in May 1989 in North Bay, one duct is made from a phenolic water-based resin, a relatively recent introduction to the engineered line of Schonberg mine ventilation products, and the other identical-sized duct is made from a commercially available Class 1 fire-retardant polyester resin. These ducts are easily distinguished by color, as the phenolic duct is normally pink-orange color when freshly manufactured and turns to reddish-brown coloration with aging. The polyester resin is white and will darken to an off-white color with aging. Both of these ducts in the fire test were manufactured in North Bay in January 1989 and deliberately left in an outside environment to age and simulate ducting which would be representative of ducting stored at a mine site. Test 1. Polyester duct. This duct shows how the rapid spread of the flames occurs when the heptane is ignited and the polyester reaches the flammability point. The charring effect of the 10-foot length of duct is noticeable with flame visible at the top of the duct. Even when the heptane has burnt itself out, the polyester duct continues to burn very strongly, and acrid black flames are generated, although the toxicity of the flames were not measured in the test. It is, however, known that since the flame retardant additive in the resin contains antimony and halides, the smoke generated contains these compounds. The polyester resins are petroleum-based products, unlike the phenolic resins, which are water-based. Test 2. Phenolic duct. The 600 milliliter of heptane ignited in the test shows that the chimney effect evident in the vertical test has significant serious implications for vertical installations. The Bureau of Mines report cites temperatures of up to 1,000 degrees centigrade being reached at the top of the duct during the burn time. In the test, the duct being water-based will blister on the internal surface and water vapor is produced. Upon the completion of the burning of the heptane, no afterburn is evident in the phenolic ducting, and the walls of the duct remain competent and would support the flow of air to an underground environment if necessary. We at Schonberg have discontinued the manufacture of polyester mine ventilation ducting in favor of the phenolic resins.